Okay, so we're on page 6 in the packet, and we're going to do 3 examples together. So a particle moves along the x-axis. Its position is given by a continuous function x of t. Selected values of x of t are shown in the table below. Explain why there must be a time at which x of t equals 1. Okay, so just a visual for what is going on here. So here's the x-axis, and we've got a particle, which I'll use this panda sticker for. So we've got this particle, and it's moving up and down along the x-axis. And at time, so when we start keeping time at time t equals 0, the panda is located at -5. And then 2 seconds later, it is at -1. And then 1 second later, it's at 4. 4 seconds, or 3 seconds later, it's at 5. And then 4 seconds later, it's back to -1. Okay, so the particle is traveling along the x-axis. Explain why there must be a time at which x of t equals 1. So they're saying explain why there must be a time where the panda's position is at 1. And yeah, we passed 1. Okay, so you can kind of see like how that has to be the case, but we have to use the intermediate value theorem to explain why. Okay, so the first step is to find an appropriate subinterval. So we've got this big interval from 0 to 10, but within it there's a bunch of subintervals, like 0 to 2, 2 to 3, 3 to 6, even like 0 to 6, that would be a subinterval. So we have to find a subinterval that has this value 1 between the y values of the endpoints of the interval. Okay, so I'm just going to find one. Like we could use 2 to 3 for sure, because 1 is between -1 and 4. We cannot use 3 to 6 because 1 is not between 4 and 5. We could use 6 to 10 because 1 is between there. So yeah, we'll just use 2 to 3. So this is optional to write, guys, but I think it would help. Optional to write this part. Okay, so let me just do like an expanded table with 3 columns. Okay, now, so I already chose that I'm going to use that subinterval there. So I'll put 2, 3. Okay, there's those. And x of t is continuous, I know that. And so they want me to explain why there's got to be a time where this is happening in the table. All right, so must. All right, so the IVT says that t exists. All right, now let's say y. So 1. So x of t is continuous on 2 to 3. Okay, so I'm going to state the subinterval that I'm using on 2 to 3. And then the second step, x of 2, which is -1, is not equal to x of 3, which is 4. Okay, and then the third step, -1 is less than 1 is less than 4. Okay, now let me put a little box around those. So if I have those 3 conditions satisfied, then by the IVT, there must be a time t, comma, 2 is less than t is less than 3, at which x of t equals 1. Okay, now this next one. So a particle moves along the x-axis. Its velocity is given by a continuous function v of t. Selected values of v of t are shown in the table below. Explain why there must be a time at which V of t equals 3. Oh, by the way, yeah, this is very important, guys. They have to tell you that the function is continuous if you're even gonna, if you're gonna be able to use the IVT at all. Okay, so that has to happen. All right, now, okay, so the velocity of the particle, it's not telling us its position, but I know at time equals 0, the particle is traveling with a speed of 1 left on the number line. And I should have talked about this in class a little bit. Hopefully I did already. But if velocity is negative, that means we're moving left on the x-axis. If the velocity is positive, we're moving right on the x-axis. And then the number itself, like the positive value of the number, just tells you the speed. Okay, so let me find a subinterval. And so I'm going to look at the y's. I need to find two y's that 3 is between. I could do 0 to 2. I could do 2 to 5 even. Let me do 2 to 5. Okay. So I'll just do a little table. I know that is continuous. And I want this time t to exist where the velocity is 3. And I'm using 2 to 5. So 2 to 5, 4 and 2. Okay, so this function is continuous. This number is between 4 and 2. So basically and 4 and 2 are not equal. So basically we've got it. So IVT says must exist. All right, and you don't need to show that table. I just thought it might be beneficial for some people. Okay, number 1. So I gotta say that V of t is continuous on 2 to 5, first condition. Second condition, V of 2 is equal to 4, not equal to V of 5, which is 2. And then the third condition, we've got 4, 3, and 2, but the inequality signs have to be going that way this time because the alligator eats the bigger number. Okay, then by the IVT, there must be a time t, 2 is less than t is less than 5, at which V of t equals 3. Okay, so now we're going to turn to page 8, and this one won't take very long. So page 8, the intermediate value theorem using a subinterval. So we already kind of talked about this, but here's the example together. Directions. Given that f is continuous, okay, that's important, on the closed interval 4 to 15, and the table of values below, which is right here, so part A, how many zeros between 4 and 15 are guaranteed by the IVT, the intermediate value theorem? So guys, you just check like the consecutive y values and see if 0 is between there. So is 0 between -3 and -5? No. Is 0 between -5 and 8? Yes. Is 0 between 8 and -1? Yes. So we've got two zeros there. So I'll say A. 2 zeros guaranteed. And then just for your notes, guys, maybe you should say because -5 is less than 0 is less than 8. And -1 is less than 0 is less than 8. Okay, or here you could have said 8 is greater than 0 is greater than -1 for that part. Okay, so 2 zeros guaranteed. Now part B. state the subintervals that can be used to explain why the zeros exist. So the subintervals, this is what you'll be using like in the very first condition. So the subintervals would be 7 to 12, 7 to 12, comma, 12 to 15. So if you were going to do an IVT explanation, you would use either of those intervals. Okay. Now part C. How many values of C, where C is between 4 and 15 again, does the IVT guarantee for which f of C equals -4? All right, so how many values of C, 4 is less than C is less than 15, does the IVT guarantee for which f of C equals -4? Okay, so I'm going to do the same thing I did with 0. So let's see. I'm trying to find consecutive y values that -4 is between. So -3 and -5, yep, -4 is between there. -5 to 8, yes again. 8 to -1, no. Okay, so two values guaranteed because -5 is less than -4 is less than 8. Oh yeah, and then -3 is greater than -4 is greater than -5. All right, so you could do it. So there's like y for your notes. All right, and then part D, same as part B before. State the subintervals that can be used to explain why the values exist. So the subintervals would be 4 to 7. You gotta be closed. 4 to 7 and 7 to 12. Okay, guys, that's it.